IGCSE Computer Science Syllabus Statement 1.3.1c, produce truth tables for given logic circuits. So, in the last video we looked at two logic circuits, building them in a logic simulator, but we didn't look at the truth tables for those circuits. So this is what we're going to be doing today. So, yeah, that's pretty much it. So, if you don't remember what a truth table was, watch the first logic video, because that video has the truth tables for all of the logic gates. A truth table is basically a table which shows you the output of a gate or circuit with all possible inputs, and you'll see what I mean in a second. So let's take a look at this logic circuit. This is the first one that we made in the last video, if you recall. So we have two inputs, A and B, and an output X. Now what we can do to make our lives easier is to add intermediate or middle values. So like L, M, and N. So these will be the outputs in these three gates here, or the outputs of these three gates here, just to make life a little bit easier for us when we do our truth table. So basically L is not A, M is A and L, and N is A nor B. So it's pretty much like that. And then of course X is M, X, or N. So we'll look at that in a truth table right now. So we have A and B as inputs. We have 0, 0, 0, 1, 1, 0, 1, 1. So all the possible inputs of the circuit. Then we have L, M, N, and X. So these are the intermediate values, and this is the output. So not A is simply not A. So not 0 is 1. M is A and L. A and 1, well, 0 and 1 makes 0. N is A nor B, so that would be 1, because it's like, it can only, well, basically, yeah, it can only be 0. Yeah, it's actually, it can only be 1 if both of these are 0. So if any of these were to be 1, or even both of them were to be 1, then this would be 0. That's what I meant to say. And of course the output, which is M, X, or N, we just take a look at these, and it looks like the output will be 1. So then we have 0 and 1. So not A is of course again 1. A and L, so that would be 0 and 1, so that would be 0. A nor B, so this would be 0, because as said, it can only be 1 if both of these are 0. And M, X, or N has to be 0. And we could do the same thing. This would be 0, 0, 0, 0, 0, 0, 0, 0. So we get the output of the circuit 1, 0, 0, 0. And as said in the last video, this is the truth table for a NOR gate. So we could have, again, simplified this entire circuit into this gate right here. So there's no need to buy this part, or this part. You need to buy this part. So in the exam, you're going to have to, like, well, you're probably going to have to. I'm going to say probably because I don't know what I don't know what's going to be on the exam, but you're probably going to have to simplify a logic circuit into a logic gate. And this is pretty much how to do it. You look at the output of the truth table for the circuit that you've made and think to yourself, well, what if this is similar to any of the gates that I know? That's pretty much what you do. So now we get to this bigger logic circuit, and this is the one, if you remember, that we made with all of the 7 gates that we learned about. So we have our inputs, our intermediate values, and our output. So what I've decided to do is, well, I mean, actually, no, forget what I was going to say. What you could try to do is try to, wait here, let me just set this up first. So we have all our possible values for the inputs, and of course we have our other values. So what you could do on your own, if you want to, is you can try to figure this out for yourself just to get some practice. If you don't want to, just continue watching and we'll go through it. Okay, so let's look at L first. That's A and B. So 0 and 0 must make 0. A or B, 0 or 0 must make 0. This must make 1. L nor M must make 1. Because if you remember, in the OR gate, the output is 0, 1, 1, 1. So in the NOR gate, the output must be 1, 0, 0, 0. So, which means that if both inputs are 0, then the output is 1. L NAND O must be 1, because in an AND gate, this would be 0. M XOR N, this must be 1, because there's only one 1 in the input. P XNOR Q must be 1, because an XOR gate would output 0. So you get the idea, pretty much. So it's the same for this row, and so on. And it's good to get practice doing this on your own, because in the exam, of course, you might have to do this. So that's pretty much it. Sorry that I didn't go through every row. I thought that it would be quite tedious, because you sort of get the idea of how this works already. So thanks for watching, and I'll see you guys when we look at the next statement.